Lesson 3-4, solving quadratic equations by factoring. Now we've solved quadratic equations by graphing. So factoring is another form of doing this. So the vector form of a quadratic equation is 0 equaling a times x minus p times x minus q, where a cannot equal 0. In the equation, p and q represent the x-intercepts related to the function. So for example, 0 equals x squared minus 2x minus 3 can be written in the factor form of x minus 3 times x plus 1. And its related graph has x-intercepts of -1 and -3. Now, how did they get to that point? You find two numbers you multiply to get -3, but add together it gives you -2. -3 times -3 times 1 is -3. -3 plus 1 gives you -2. So when we are solving these, if it's factorable, that might be a quicker route than to graph that. So the zero product property for any real numbers a and b, if a times b is 0, then either a is 0, b is 0, or both a and b are 0. So when you do it in factored form, you want to find the zeros, means your y is equal to 0. So when you factor it, you have two binomials, make them all equal to 0, and then solve for x. So the factor is find two numbers you multiply to get your c, but add those same two numbers together to get your b. So in this example, we're going to see examples with a leading coefficient of 1 and a leading coefficient bigger than 1. Let's take a look at an example. Factor by using the distributive property, which just means you're just factoring it. Okay, so the first thing I need to do is have everything to one side. So I'm going to subtract x on both sides, and now I have 12x squared minus 3x equaling 0. Now I think 12x squared and 3x, the greatest common factor of those would be 3, and I can take an x out of them. That leaves me with 4x minus 1 equaling 0. Now I make each factor equal to 0. And then I just solve for x. So here I just divide by 3, and I would have x equaling 0. And over here I add 1 for x equaling 1, then divide by 4, x would equal 1/4. So my two solutions here would be 0 and 1/4. Next one, I'm going to add 5x both sides here and have 5x squared plus 20x equaling 0. I can factor out a 5x, and that leaves me with x plus 4 equaling 0. Make each factor equal to 0, so 5x equaling 0 and x plus 4 equaling 0. Divide by 5, and I have x equaling 0. Subtract 4 here, and I would have x equaling a -4. Moving on to our next example, example 2. Here we're going to factor a trinomial. Before we just had binomials, here we factor a trinomial. Same thing here, we need to make it equal to 0, and then we move from there. So I'm going to subtract 18 here, and now I have x squared minus 6x minus 27 equaling 0. So now I have to think, what do I multiply to get -27? If I take those same two numbers and add them together, then it gives me a -6. So I know that 9 and 3 gives me 27. I know the difference of 9 and 3 will give me 6. So now I have to figure out which number is negative. So if I do a -9 plus 3, that gives me -6. That means -9 plus or times 3 gives me -27. So I would have my two binomials. I would have x minus 9 and x plus 3. That would give me this trinomial here. Now I just make each equal to 0. So I'm just going to make this equal to 0, this one equal to 0, and solve for x. So add 9, and I would have x equaling 9. Subtract 3 here, and x would equal a negative 3. So my two solutions would be 9 and negative 3. Next one, x solve this one, x squared minus 4x plus 5 equals 101. I'm going to subtract 101, and I have x squared minus 4x minus 96 equals 0. So I got to think, what do I multiply to get negative 96? But add the same two numbers together, and I get a negative 4. So let's think, 96 divided by 14 does not work. 96 divided by 12 gives us 8. So 12 and 8 would work. Now I got to think which one has to be negative. 12 would have to be negative because negative 12 plus 8 gives me a negative 4. So my two binomials would have x minus 12 and x plus 8. Solve by adding 12 on both sides here. X would equal 12. Here, subtract 8, and I would have x equaling a negative 8. Example 3, we have a word problem. It says the equation d equals vt plus half at squared represents the displacement d of a car traveling at an initial velocity v, where the acceleration a is constant over a given time t. Find how long it takes a car to accelerate from 30 miles per hour to 45 miles per hour if the car moved 605 feet and accelerated slowly at a rate of 2 feet per second squared. So to solve this one, we first need to make everything in feet. This is in miles per hour, and this is in miles per hour. I want to convert this 30 miles per hour to feet per second because our rate here is feet per second squared. So I need everything to be the same units. So I'm going to start with 30 miles per hour. I need to go to feet, so this would be 5,280 feet in 1 mile. The mile labels cancel out. And now I have to go from hours. So 1 hour is the same thing as 3,600 seconds. And when you do the math, 30 times 5,280 divided by 3,600, you get 44 feet per second. So that is our initial velocity. So if I have d, and the d is the displacement in miles. So they had, or in feet. So this one is 605 feet. So I have 605 feet equaling the initial velocity of 44 feet per second, 44t, plus 1/2. The a is our acceleration at a rate of 2 times 2d squared. So now if I make this equal to 0, this would be minus 605 on both sides. I now have 0 equaling t squared, because half of 2 is 1, plus 44t minus 605. And now I have to factor that. So I got to think, what do I multiply to get negative 605, and together gives me 44. So think 605, if I divide that by 11, I get 55. So this would be plus 55 and a minus 11. Because 55 times a negative 11 gives me a negative 605, and 55 plus a negative 11 gives me a positive 44. Now if I make each of these equal to 0, subtract 55, I get t equaling 55, negative 55, or here adding 11, and t equaling 11 seconds. Now the only one that would make sense here would be a positive time. So the only one that would work would be 11 seconds. Next, a clothing store is analyzing their market to determine the profitability of their new dress design. If p of x equaling negative 16x squared plus 1,712x minus 44,640 represents the store's profit when X is the price of each dress. Find the prices at which the store makes no profit on the design. So the first thing I want to do is just factor what I have there. So if I factor out a negative 16, that will give me x squared minus 1712 divided by negative 16 gives us a negative 107x, and then a negative 44,640 divided by negative 16 gives us a positive 2,790. So I got to think which of these two numbers multiply give us 2,790. If I choose 11, or letter A, 11.25 times 15.50 gives me 174.375. So I know it can't be that one. Let's try B. 45 times 62 gives us 2,782. And then if I were to subtract them, or if I were to add them together, and remember these would be like say it would have been x minus 45 times x minus 62. If I were to take negative 45 plus a negative 62, that gives me a negative 107. So B would actually be the correct answer there. Next, a farmer planted pumpkins in a rectangular garden measuring 79 feet by 113 feet. He decides to put a fence around the pumpkins that is equidistant from each side of his garden. If the area of the land encompassed by the fence is 10,115 square feet, how far is the fence from each side of the garden? So to solve this one, we need a diagram will help with that. So if this is the area of the garden that he planted, so this is like 113 and this is 79. Then he's planting a fence, putting a fence all the way around, and that has an area of 10,115. This part is the same distance as this part, so if I just say these are x, it means this is also x and this is also x. So I have 2x plus 113 for this side times 2x plus 79 for this side. That has to equal the area of 10,115. So if I FOIL this, this gives us 4x squared, and then 2x times 79 plus 113 times 2x will give us 384x, and then 113 times 79 will give us a positive 8,927. This has to equal 10,115. From this point, I need to make this equal to 0, so I'm going to subtract 10,115. And I get 4x squared plus 384x minus 1188 equaling 0. And I can factor out a 4 here, and that gives me x squared plus 384 divided by 4 gives us 384 divided by 4 gives us 96. X minus 1188 divided by 4 gives us a negative 297 equaling 0. And then I can just factor what I have in parentheses here. So I got to think, what do I multiply to get negative 297 and add them together gives you negative 96. So if I were to do, let's just say a negative 3 and a positive 96, or not 96, 99, 99 times negative 3 is negative 297. Make each of these equal to 0. And I would have to add 3 here, add 3 here, subtract 99 here, subtract 99 here. So I can have x equaling 3 or x equaling negative 99. Now, I can't have negative distance, so the only one it would be is the positive. So it would be 3 feet is how far each side of the fence is from the garden. Next, example 4. Solve 3x squared plus 5x plus 15 equals 17 by factoring. You'll notice that the leading coefficient is not 1 anymore. First, let's make this equal to 0. I have 3x squared plus 5x minus 2 equaling 0. If there's something I can factor out of all of them, I would. But here I can't factor anything, so I'm going to use the AC method. And the AC method just means take the A times our C and get a new C term. So now I have to think, what do I multiply to get negative 6? But add them together gives me a positive 5. So I know that 6 times negative 1 is negative 6, and 6 plus a negative 1 is 5. So I'm going to put 6 here. This would be 6x, and this would be a negative 1x. Bring down the sides. So now we have 3x squared plus 6x. And over here I have negative x minus 2. Now I can factor. I can take out a 3x here, and that leaves me with x plus 2. Over here I can take out a negative 1. That leaves me with x plus 2. So my answer, I would have 3x minus 1, because it's everything on the outside, times x plus 2, which is what my parentheses were. Now if I make each of these equal to 0, I can now solve. So let's do that over here. So 3x minus 1 equaling 0. Add 1 to both sides. I have 3x equaling 1. Divide by 3. X would equal 1/3. On the other one, I have x plus 2 equaling 0. Subtract 2 on both sides, and I would have x equaling a negative 2. And that would be my solutions. Next, solve this one. I'm going to subtract 13. And now I have 4x squared plus 12x minus 40 equaling 0. I can factor out a 4 here. That leaves me with x squared plus 3x minus 10 equaling 0. And then I can factor what I have in parentheses. So I think, what do I multiply to get negative 10? Add them together gives me a positive 3. This would be a positive 5 and a negative 2. And then I have a 4 on the outside. And make each factor equal to 0. 4 can never equal to 0, so I don't worry about that. X plus 5 equals 0, and x minus 2 equaling 0. So here I subtract 5, and I have x equaling a negative 5. Over here, add 2, and I have x equaling a positive 2. My two solutions are negative 5 and a positive 2. Next, solve this one. I'm going to subtract 9. I have 2x squared minus x minus 15 equals 0. There's nothing in common with all of them, so I'm going to do the AC method, which gives me negative 30x squared. Now I think, what do I multiply to get negative 30? But m together gives me negative 1. This will be negative 6x and a positive 5x. Bring down the sides, 2x squared. One binomial, bring down the minus 15. It's the other. And then I factor. So I can factor out 2x. That leaves me with x minus 3. Over here, I can take out a positive 5. That leaves me with x minus 3. So I have x minus 3 and 2x plus 5. Those are what I'm going to use to simplify. So I have x minus 3 equaling 0 and 2x plus 5 equaling 0. Add 3 to both sides. I have x equaling 3. Here, subtract 5. 2x equaling a negative 5. Divide by 2. I would have x equaling a negative 5 halves. Last part of our lesson today is solving quadratic equations with special products. So these are special ones which you're going to use for factoring. So factoring differences of squares means you have two perfect squares and you're subtracting the two. Then we have factoring perfect square trinomials, where you have a perfect square trinomial and you can factor it using the formula a squared plus 2ab plus b squared will equal a plus b squared. If you look at the difference of two squares, a squared minus b squared, it's the same thing as saying a plus b times a minus b. Not all quadratic equations have solutions that are real numbers. So in some cases, the solutions are complex numbers of the form a plus bi, where b cannot equal 0. For example, you know that the solution of x squared equals negative 4 must be complex because there is no real number for which its square is negative 4. If you take the square root of each side, you get x equaling positive and negative 2i. So our first example, I have 81 equals x squared. We need to solve by factoring. So I'm going to rewrite this as x squared equals 81. Find the square root to undo a square. I end up with x equaling a positive and negative 9. Our next one, I have x squared equaling 529. Undo a square by finding the square roots. And I have x equaling a positive and a negative. And the square roots of 529 gives us 23. So a positive and negative 23. Next one, I have x squared equaling 256. Find the square root of both sides. I know they're saying solve by factoring, but I think it's easier just to undo the square by finding the square root. So this would be x equaling a positive and negative. Square root of 256 would give us 16. If I were to do this factoring wise, I would have x squared equaling 256. I can subtract 256 to both sides, and I would have x squared minus 256 equaling 0. And this is a difference of two squares. So I have an x here and an x here. One's positive, one's negative. Square root of 256 is 16. Make them equal to 0. I would have minus 16 here and add 16 here. And there's where you get your x equaling 16 and negative 16. That's just another way of doing that. The quicker way is just find the square roots of both sides. Next, solve this one with perfect square trinomial. So this has to fit a squared plus 2ab plus b squared, or a squared minus 2ab plus b squared. The first thing I want to do is get everything to one side and simplify this. And with these, we do want to make sure that our square is going to be positive. Now right here, I just noticed this should not be a square here. This should be just negative 22y. Now if I subtract 26y and add 13, I now have 16y squared minus 48y plus 36 equaling 0. Now for perfect square trinomials, the first term has to be a perfect square, the second has to be a perfect square. And if you take the square root of those, that's 4 and 6. 4 times 6 is 24, and if I double that, That should give me the middle number of 48. So I have two binomials. So this would be 4y and 4y, because that gives me 16. 36, or 36 is 6 and 6. Since this is positive, I would have to have a negative and negative. So a negative times a negative gives me a positive. And adding two negatives, so negative 24x plus negative 24x, or negative 24y plus negative 24y is negative 48y. Make each of these equal to 0. I would add 6. I would now have 4y equals 6. Divide by 4. And I would have y in simplified form as 3 halves. Over here, add 6. I would have 4y equaling 6. Divide by 4. Same thing, I would get the same answer. There's only one solution here, and that would be y equals a positive 3 halves. Next, factor perfect square trinomial here. So I'm going to subtract 10x and add 1 on both sides. I now have 16x squared minus 32x plus 16 equals 0. So the square root of 16x squared is 4x. So I start 4x in both binomials. Square root of 16 is 4. Since this is a minus, both of the sides have to be, inside the binomials have to be minus. And now I have 16x. Negative 16x plus negative 16x is negative 32x. Make equal to 0. But since they're the same, I only need to solve for one of them. So I'm going to add 4 to both sides. And I have 4x equaling 4. Divide by 4. X would equal 1. So my solution here would be 1. Next, solve this one. I'm going to add 24x and add 27 to both sides. Now I have 9x squared plus 54x plus 81 equaling 0. So binomials, so square root of 9x squared is 3x. Square root of 81 is 9. Since everything is positive, these are both going to be positive. So I think 27x plus 27x is 54x. 9 times 9 is 81. 3x times 3x is 9x squared. Since they're both the same, I can just solve for one of them. So I'm going to subtract 9 on both sides. 3x equaling a negative 9. Divide by 3. X will equal a negative 3. And our last slide, our last problems, solve with complex solutions. Here we're going to solve by factoring, and then we're going to check it. So the first thing, I have x squared minus 104, or equals a negative 144. So if I add 144 to both sides, I now have x squared plus 144 equaling 0. Now if I'm factoring this, I can do a difference of two squares. So I have x squared minus, and this would be a negative 144. So if this is a negative 144, I can do a negative, so square, since that would be a square root of a negative number would be an I. And then, so really, let me write this over here. So if I had x squared minus a negative 144 equaling 0, I can write this as a difference of two squares. So this would be x squared minus, here I have an I for the negative. Square root of 144 is 12. So if I square that, I get the positive 144 here, equaling 0. So the difference of two squares would be x and x minus 12i and plus 12i. Make them equal to 0. I would have to add 12i x would equal a positive and a negative 12i. So here I would just subtract 12i. That's how you get your positive and negative 12i. A shorter way would just be if you have x squared equaling a negative 144, find the square root of both sides, and x would equal positive and negative. The negative square root is I, square root of 144 is 12. That's the other way, but if you were factoring it, you can see the factoring there. Next one, I have x squared equals a negative 49. If I do the factoring, I would add 49 to both sides. And now if I do it as a difference of two squares, I would have x squared minus, and this would be a negative 7 squared. This negative 7 squared is 49. To make this a plus 49, I would have a negative here. Actually, this would be a 7i. So 7i squared minus, or x squared minus 7i squared. This would equal 0. So all I'm doing is just find the square root of that. So now I'd have x minus 7i times x plus 7i. Because that's how you're going to get to a negative 49i squared, which would be a positive 49. Make them equal to 0. Solve by adding 7i. And I would have x equaling a positive and negative 7i, because here you would subtract 7i. And there's your answer. But again, the quickest way would just do square both sides. And I would have x equaling a positive and negative. The I for the negative, square root of 49 is 7. But either way would work. That is our lesson on solving quadratic equations by factoring.